Right now, as you're reading this, somewhere above your head, a satellite is racing by at 7.5 kilometers per second. You can't see it, but it's there. A tiny metal dot helping your GPS find the way, and your phone catch a signal. And here's the strange part. This satellite will most likely become junk one day, and then that junk can kill another satellite, just by hitting it at a speed 20 times faster than a bullet. This isn't science fiction. It's already happened. The question is how an ordinary piece of orbiting metal becomes a weapon, and why it matters to you, personally. Let's start from the very beginning, from October 4th, 1957. On this day, the Soviet Union launched Sputnik 1, a shiny sphere weighing 84 kilograms, only slightly bigger than a beach ball. It was the first man-made object to reach Earth orbit. It sent a simple signal, beep, 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 and the whole world listened to it on the radio, holding its breath. Sputnik 1 operated for 3 months, then burned up in the atmosphere. Clean, tidy, no consequences. But back then, no one thought about what would happen once there weren't just one satellite in orbit, but 10,000. Let's jump to 1978. An American NASA scientist named Donald Kessler publishes a paper that, at the time, sounded like a paranoid fantasy. He proposed, if the number of objects in orbit exceeds a critical mass, collisions will start generating new debris, and that debris causes new collisions, a chain reaction, without end. Today this is called the Kessler syndrome, and it's no longer considered fantasy. Here's why it matters, really matters. Low Earth orbit currently holds more than 130 million pieces of debris, larger than a millimeter. Of those, about 1 million are larger than a centimeter, enough to punch straight through a satellite's hull. It's not about size, it's about speed. Objects in orbit move so fast that even a 10-gram bolt releases energy comparable to a grenade explosion on impact. Think about it, a nut, an ordinary nut, capable of destroying a satellite worth hundreds of millions of dollars. And now, the story that proved Kessler was right. February 10th, 2009. Above Siberia, at an altitude of almost 800 kilometers, 2 satellites collide. The American Iridium, 33, active and operational, and the Russian Cosmos, 2251, long decommissioned. The collision happened by accident. No one planned it. No one could prevent it. The result? More than 2,000 large fragments. Instantly. It was the first accidental collision in history between 2 intact satellites in orbit. And it made one thing clear. Space isn't as big as it seems, but there was another episode that made the problem worse. A year earlier, in 2007, China conducted an anti-satellite weapon test, destroying its own old Fengyun 1C weather satellite with a missile. One hit, and more than 3,000 new fragments appeared in orbit. 2 events, one result: the sky above your head became thicker with scattered metal shards. But here's the catch. Debris doesn't just float in space, it moves along orbits, just like real satellites, which means sooner or later, the paths cross again. The International Space Station is periodically forced to change its orbit to dodge debris. Since 1999, the station has performed dozens of such avoidance maneuvers, in some years, several times per season. Imagine, a multi-billion-dollar station with people on board forced to dodge debris, which was once someone's communications satellite or military spacecraft. A bit of relief. The good news is that at this altitude, at least you get a great view of Earth while dodging scrap metal. Now, to the scale of today's problem. There are now more than 10,000 active satellites operating in orbit. Just 10 years ago, there were fewer than 2,000. The reason? Mega constellations, like Starlink, which in a few years have put thousands of small internet satellites into orbit. This is convenient for you. Fast internet, even in a remote village. But every new satellite is one more object that will eventually fail, and it will either burn up in the atmosphere or stay there forever, waiting for its own collision. Scientists from the European Space Agency have calculated, if humanity doesn't start actively removing debris from orbit, by the middle of this century, some orbital altitudes will become so contaminated that using them will become extremely risky. Not impossible, but extremely risky. And here's where we get to the most interesting twist. Every call you make, every GPS message, every weather forecast, all of it goes through satellites. If orbit becomes unusable, it won't be some abstract space industry that suffers. You will. Your phone, your internet, the forecast that tells you whether to bring an umbrella tomorrow. That's exactly why several companies and agencies are now developing active debris removal technologies. The Japanese company Astroscale is testing catcher satellites capable of grabbing failed objects with a magnet and dragging them into the atmosphere to burn up. The European agency is planning the ClearSpace 1 mission, the first operation deliberately designed to catch and destroy one specific piece of debris. It sounds like picking up space litter by hand, which is essentially what it is. So here's the full picture. It started with a shiny little sphere in 1957. It continued with a scientist warning in 1978, which no one took seriously. It became reality in 2007 and 2009, when 2 collisions and 1 explosion created thousands of new threats. It has grown to 10,000 satellites today, and now it's turning into a race. Will humanity manage to clear the orbit before it becomes unusable? That satellite flying above your head right now, it will fall silent one day. It will run out of fuel, its electronics will fail, its service life will end. And then it will have only 2 paths: burn up in the atmosphere or stay there, turning into a projectile, waiting for its target. We've surrounded our planet with a thin layer of technology we depend on every day, and at the same time, created a minefield of our own debris around it. Maybe the most human thing about all this is that we built our path to space so fast, we're still learning how to clean up after ourselves. So let's start with how you actually catch debris that doesn't want to be caught. The first problem is obvious. The fragment has no engine, no stabilization system. It just tumbles through the void, sometimes spinning at several rotations per minute. Try catching a spinning top that's whirling at 7 kilometers per second and falling sideways into your hands. That's exactly why the Japanese company Astroscale mission we mentioned is called ELSA-D, End of Life Services by Astroscale. In 2021, they launched a pair of satellites. One, a magnetic hunter, the other, a purpose-built target with a metal plate. The goal of the experiment was simple: practice capturing an object that's tumbling uncontrollably before trying it on real debris. The result was encouraging. The hunter successfully docked with the target several times in a row, practicing different approach scenarios. But here's the catch: most real space debris doesn't have a convenient magnetic plate. It was never built to be caught in the first place. Think about it. Engineers in the 1970s and 1980s launched satellites without even considering what to do with them after they died. Just launch it and forget it. We're paying for that now. That's exactly why the next generation of satellites is being designed differently. The concept of design for demise emerged. Satellites are now deliberately made from materials that fully burn up in the atmosphere before reaching the ground. No titanium tanks tough enough to survive atmospheric entry and crash onto someone's roof. Yes, that has actually happened too. In 2022, Falcon 9 rocket debris fell onto a farm in Washington state. No one was hurt, but the incident reminded everyone what flies overhead eventually comes back down. And now, a twist many don't expect. It turns out the biggest threat isn't large debris, like rocket fragments. They're tracked, their paths are predicted, they're avoided. The real danger is debris sized between 1 and 10 centimeters. Too small to be reliably detected by radar from Earth, too large for a satellite's hull to withstand. The space surveillance network run by the US military tracks roughly 30,000 objects, larger than a tennis ball. But as we mentioned, the actual number of fragments, larger than a centimeter, is around 1 million. That means 97% of potentially deadly objects are flying invisible. Here's why it matters. Really matters. Satellites today are forced to build in blind protection. The International Space Station is armored with special multi-layer Whipple shields, a thin outer layer of aluminum, separated by empty space from the inner hull. The idea is simple. The fragment shatters into fine dust against the first layer, and the second wall absorbs the impact of that dust. It works against objects up to about 1 centimeter in size. Against anything larger, only an avoidance maneuver. But avoidance maneuvers aren't free. Every time, the station or satellite burns fuel. And you can't buy fuel at a gas station in orbit. It has to be delivered by rocket, and every extra maneuver is weeks or months subtracted from the craft's service life. A bit of relief. Imagine your car having to dodge invisible bricks on the road, and every swerve shortens your engine's lifespan. That's roughly how the ISS has been living for the past 20 years. Now, what makes the situation truly urgent? In 2023, the European Space Agency officially acknowledged for the first time object density at some low orbit altitudes is already approaching the Kessler syndrome threshold. Not exceeded, but close enough that further unchecked growth in the number of satellites could trigger a chain reaction with no way to stop it. If that happens, orbit at a certain altitude will become unusable for decades, maybe centuries. This is where the real race unfolds. And on one side, companies like SpaceX, OneWeb, and Chinese operators launching thousands of new satellites every year to bring internet to the whole globe. On the other, agencies and startups trying to build cleanup infrastructure before the sky turns into a junkyard. ClearSpace 1, the European Space Agency mission we mentioned, is now scheduled for the end of this decade. The goal? Capture a specific large Vega rocket fragment that's been in orbit since 2013 and bring it down out of orbit together with itself. The first mission in history entirely devoted to destroying one specific piece of debris. Sounds like an incredibly expensive way to throw out one trash bag, but that's exactly how every recycling system begins, with the first bag hauled out by hand. So here's the full picture, now complete. It all started with a shiny little sphere in 1957. It passed through a scientist's warning that no one listened to. It materialized into two disasters, a weapons test and an accidental collision. It grew to 10,000 working satellites and 1 million invisible killers. And now it's turning into a race between those polluting orbit and those trying to clean it up in time. That satellite flying above your head right now is part of that race, whether you like it or not. Every call you make, every map, every weather forecast, depends on whether humanity wins this race to keep the sky clear. Maybe the most surprising part isn't that we cluttered orbit so fast, it's that we thought to go there at all, without even knowing how to clean up after ourselves. Now, a question for you. If humanity had to choose only one option, either permanently stop launching new satellites or take the risk and one day lose access to orbit entirely, which would you choose? Write your answer in the comments. I'm genuinely curious what most people will decide.